Hi, my name is Philippa, and this is my Lab 2 for Physics 1. Intro, Purpose, and Procedure. The purpose of this lab is to show projectile motion of an object when thrown and displayed by Newton's second law. The procedure is placing a measuring stick on a flat surface and throwing a paper ball into the air, uploading the video to Tracker for analysis and creating both an X and Y position time graph from Tracker, using GlowScript data to create an ideal computational model of both the position, time, and velocity graphs, comparing and analyzing both the Tracker and GlowScript data, and explaining the potential experimental flaws that could contribute to their differences, as well as looking at the scenario with drag and no drag. Here are the relevant equations. Newton's second law: acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Consequences: the net force should be in the y direction given that there is no drag. The x velocity should be constant. If drag was present, the x velocity would no longer be constant. Drag can be calculated using the bottom equation to the right. Drag equals FD v squared v hat. Here's my Tracker data. The system in this scenario is the paper ball, and the surroundings are the classroom. Tracker, however, is not factoring in drag, so the x position time graph is a straight line as the velocity is constant, and the y position time graph is a parabola as the object is being thrown in an arch, and they have a net force of gravity working on it. The net force of gravity only works in the y direction, not the x direction. Here is my GlowScript code. Time was chosen because that's when the ball was released. Like, time was chosen as when the ball was hit the ground versus when the ball was released, so subtracted. Here is my GlowScript data with drag. As you can see, the velocity x versus time graph shows a non-constant x velocity, and the velocity y versus time graph also shows a non-constant y velocity. This is due to the drag force working in the x direction and the force of gravity working in the y direction. Here's my GlowScript no drag. As you can see, the y velocity is not changed, however the x velocity is changed as there is no longer a net force working on it. Here's my GlowScript code no drag. It was pretty similar. The only thing I changed is I commented out the drag force line. Here's my Tracker versus GlowScript data. Also Tracker Y, no drag Y GlowScript, and then drag Y GlowScript. Series 1 is Tracker data Y, Series 2 is GlowScript model no drag, and Series 3 is GlowScript plus drag. Both Tracker and GlowScript show pretty similar results. The difference is maybe due to the clip imported in the Tracker being blurry, which would make tracking difficult and would make the graph slightly off. Drag made the position change more slowly in the x direction as it applies a force in the opposite direction of the velocity. Now, here are some hypothetical situations. What if the object was not thrown in an arch and instead thrown down? It would experience an acceleration in the y direction and none in the x direction. It would experience, what does this mean? Since the object is not at terminal velocity, it would have a net force acting in the y direction, making its velocity in the y direction no longer constant. The video was not super clear, meaning Tracker may have tracked it incorrectly as a source of possible error. Thank you everyone for watching my lab today. I hope you have a good day.